Hi, I'm Kaushik, studying in Tibet Hyderabad BTech CSE. Now I'm going to explain the science project. The question is that there are two pendulums hanging with angles theta 1 and theta 2. We have to find the angular momentum of pendulum of mass m1 and pendulum of mass m2. This is a chaotic system in a four-dimensional phase space with the variables theta 1, theta 2, v1 and v2. To apply Lagrange's equation, we determine expressions for Ke and Pe as the system moves in angular displacement through the independent angles theta 1 and theta 2. The x1 is L1 sin theta 1 and y1 is, taking this as positive y and this is positive x, y1 is minus L1 cos theta 1. Similarly, x2 is L1 sin theta 1 plus L2 sin theta 2 and y2 is minus L1 cos theta 1 minus L2 cos theta 2. So Ke is, we represent kinetic energy by T. Therefore, T is equals to half m1 into x1 dot square plus y1 dot square plus half m2 into x2 dot square plus y2 dot square. It can be rewritten as T is equals to half m1 L1 square theta 1 dot square plus half m2 L1 theta 1 dot square plus L2 theta 2 dot square plus 2 L1 L2 theta 1 dot 2 theta 1 dot theta 2 dot cos theta 1 minus theta 2. Similarly, the PE of the system is V is equal to m1 g y1 plus m2 g y2, which is equals to minus of m1 plus m2 plus into g L1 cos theta 1 minus m2 g L2 cos theta 2. Therefore, the Lagrangian is then L is equals to T minus C, which is equals to half of m1 plus m2 into L1 square theta 1 dot square plus half m2 L2 square theta 2 dot square plus m2 L1 L2 theta 1 dot theta 2 dot cos of theta 1 minus theta 2 plus m1 plus m2 g L1 cos theta 1 plus m2 g L2 cos theta 2. Since the generalized coordinates are now theta 1 and theta 2, Lagrangian equation becomes d by dt of dou L by dou theta 1 dot minus d by d theta 1 of L1 is equals to 0, and d by dt of dou L by dou theta 2 dot minus dou L by dou theta 2 is equals to 0. Therefore, from this we get p theta 1 and p theta 2 as these equations. Therefore, d by dt of p theta 1 on solving we get m1 plus m2 L1 square theta 1 double dot and so on. We get this equation, and on solving d by dt of p theta 2 we get this one. From here, L is equals to dou L by dou theta 1 gives this and dou L by dou theta 2 gives this. Substituting this equation and this equation in 1 and this equation and this equation in 2, we get m1 plus m2 L1 theta 1 double dot plus m2 L2 theta 2 double dot cos theta 1 minus theta 2 plus m2 L2 theta 2 dot square sin theta 1 minus theta 2 plus m1 plus m2 g sin theta 1 equal to 0. L2 theta and L2 theta 2 double dot plus L1 theta 1 double dot cos theta 1 minus theta 2 minus L1 theta 1 dot square sin theta 1 minus theta 2 plus g sin theta 2 equal to 0. Dividing 7 by m1 plus m2 into L and dividing this equation by L2, we get theta 1 double dot plus alpha of theta 1 comma theta 2 into theta 2 double dot is equals to f1 of theta 1 theta 2 theta 1 dot theta 2 dot and theta 2 double dot plus alpha of theta 1 comma theta 2 into theta 1 double dot is equals to f2 of theta 1 comma theta 2 comma theta 1 dot comma theta 2 dot, where alpha of theta 1 comma theta 2 is equals to L2 by L1 into m2 by m1 plus m2 into cos of theta 1 minus theta 2, and alpha 2 of theta 1 comma theta 2 is equals to L1 by L2 cos of theta 1 minus theta 2, and f of theta 1 comma theta 2 comma theta 1 dot comma theta 2 dot is equals to minus L2 by L1 into m2 by m1 plus m2 into theta 2 dot square sin of theta 1 minus theta 2 minus g by L1 into sin theta 1, and f2 of theta 1 comma theta 2 comma theta 1 dot comma theta 2 dot is equals to L1 by L2 theta 1 dot square sin of theta 1 minus theta 2 into minus g by L2 sin theta 2. f1 does not depend on theta 1 dot and f2 does not depend on theta 2 dot. 9 and therefore 9 and 10 equations can be combined into a single equation, a of theta 1 double dot theta 2 double dot, which is equals to 1 by alpha 2 1 alpha 2 alpha 1 1 theta 1 double dot theta 2 double dot, which is equals to f1 f2, where matrix A depends on theta 1 and theta 2. Since alpha 1 comma alpha 2 depends on these variables, A inverse is equals to 1 by delta A into 1 minus alpha 1 minus alpha 2 1, which is equals to 1 by 1 minus alpha 1 alpha 2 into 1 minus alpha 1 minus alpha 2 1. Delta A is equals to 1 minus alpha 1 alpha 2, which is equals to 1 minus m2 by m1 plus m2 into cos square theta 1 minus theta 2, which is equals to 0. Implies this matrix gives 1 by 1 minus alpha 1 alpha 2 into f1 minus alpha 1 f2 minus alpha 2 f1 plus f2. let theta 1 dot is equal to omega 1, theta 2 dot is equal to omega 2. The equations of motion of double pendulum can be written as the system of coupled first order differential equations on variable theta 1 comma theta 2 comma omega 1 comma omega 2, where d by dt of theta 1 theta 2 omega 1 omega 2 is equals to omega 1 omega 2 g1 of theta 1 comma theta 2 comma omega 1 comma omega 2, g2 of theta 1 comma theta 2 comma omega 1 of omega 1 comma omega 2, where g1 is equal to f1 minus alpha 1 f2 1 by 1 minus alpha 1 f2 comma g2 is equal to minus alpha 2 f1 plus f2 by 1 minus alpha 1 alpha 2, where alpha is equals to alpha I of theta 1 comma theta 2 and fi is equal to fi of theta 1 comma theta 2 comma omega 1 comma omega 2. This equation can be solved numerically using Runge-Kutta method.